All right, let's talk about something that can absolutely make or break your database performance: SQL indexes. Seriously, if you've ever found yourself staring at a loading screen, wondering why one query is super fast and another one just crawls, well, indexes are almost always a huge part of the answer. Let's dive in.
You know the feeling, right? You run a query on a massive table, and you just sit there waiting and waiting. As your database gets bigger and bigger, trying to find that one specific row can feel pretty much impossible. But what if you could give the database a map, a shortcut, telling it exactly where to go? Well, that's precisely what an index is. It's the solution to that needle in a haystack problem. Think of it as your database's secret weapon, a powerful speed-up tool that can completely change the game for finding information.
So, what is an index on a technical level? It's a special data structure, a lookup table, that the database uses to find data way faster. But, and this is a really important but, there's a trade-off. While indexes make reading data incredibly fast, they do add a little overhead. They can slow down data writes, like your inserts, updates, and deletes, and yeah, they take up some extra disk space. It's all a balancing act. Honestly, this is the perfect analogy. If you need to find a specific topic in a giant textbook, you don't start at page 1 and read the whole thing, right? No way. You flip to the index in the back, find the keyword, and it tells you the exact page to go to. An SQL index does literally the same thing for your data rows.
Okay, now that we get the basic idea, you need to know that not all indexes are created equal. There are two main types. Let's start with the first one, the clustered index. And to do that, let's imagine our database table is an entire library.
A clustered index is a really big deal because it's not just a guide, it dictates the actual physical order of the data on the disk. Just like a library might decide to physically shelve all its books alphabetically by the author's last name, a clustered index physically sorts all your data rows based on the column you choose. So here's the key takeaway. Because the clustered index is the physical layout of your data, a table can only have one of them. It just makes sense, right? You can't physically sort your library's books by author and by publication date at the exact same time. You have to pick one primary way to organize everything, and that's your clustered index. So, if our library is already physically sorted by author, how in the world do we quickly find a book by its title? That's where our second type of index comes in, the non-clustered index. And for this, you can think of the classic library card catalog. A non-clustered index is a completely separate thing. It's its own data structure. It's basically a sorted list of values, and next to each value is a pointer, a little bookmark, that tells the database exactly where to find the full data row. It doesn't move the books on the shelf at all. And this is where things get really flexible. Since these non-clustered indexes are just separate lists, you can have a bunch of them. It's like having one card catalog sorted by title, another one for genre, and maybe even a third for the year it was published. Each new non-clustered index is just another fast way to search your data, without ever having to rearrange the whole library. Okay, let's put them head to head. The clustered index is the table, physically sorted. You only get one. It is amazing for when you're searching for a range of things because all that data is sitting right next to each other on the disk. The non-clustered index points to the table. It's a separate map. You can have lots of these, and they are perfect for zapping right to a specific single record.
So, knowing the difference is one thing, but the real power comes from knowing when to use each one. This is all about picking the right tool for the job you're trying to do.
It's pretty straightforward. You'll want to use your one and only clustered index on a column you often use for sorting or for range queries. Think about find all the orders placed in the month of May. For non-clustered indexes, think about all the other ways you look up data. The columns you always put in your where clause, like looking up a customer by email address or a product by its SKU. Those are perfect candidates.
Okay, enough theory. It's great to talk about libraries and card catalogs, but what does this stuff actually look like when you're writing code? Let's get practical with a real-world SQL example. So let's say we've got a standard employees table. The employee ID is a fantastic choice for our clustered index. It's almost always your primary key, it's unique, it's sequential, perfect. Then, we know our HR department is constantly searching for people by last name. So, we'll create a separate, non-clustered index on that last name column to make those lookups instantaneous.
And look at that, it brings our analogy full circle. That first command, the clustered index, is telling the database to organize the entire library, all the employee data, physically on the shelves based on their employee ID. The second command creates that super efficient card catalog just for looking up employees by their last name, which points right to their spot on the shelf.
I love this metaphor. It's not about clustered versus non-clustered, as if they're competing. They work together. They harmonize. Your clustered index is like the rhythm section of the orchestra, providing the fundamental structure, the physical order of the data. And the non-clustered indexes, they're the soloists, allowing for these incredibly fast, specific lookups. When you use them together, you get this beautiful, efficient music from your database.
Look, understanding how and when to use these different indexes is a total game changer. It's the difference between a database that feels clunky and slow and one that feels responsive and finely tuned. So now that you know the score, the question is, how are you going to orchestrate your data?